Hello, my mathematicians. This is Miss Foster with Math in Focus, 4th grade, Chapter 1, Lesson 3, Adding and Subtracting Multi-Digit Numbers. You learned how to do this and have spent so much time learning it in 1st, 2nd, and 3rd grade. So this lesson really should be a quick review because sometimes when our brain doesn't have to use something we've learned for a long time, it will break the connections and it's hard to remember. But my friend, you've got this information in your brain. I promise. We're just going to do some practice to reconnect that learning. You've got it all in there. But we're also going to really think this year about what makes sense, which brings us to our essential question for much of this year. If we understand place value and its superpower, regrouping, does it matter how large the numbers are that we add or subtract? I say no. Let's see if I can convince you that I'm right. Our first problem here has 56,084, which I have modeled here with our place value chips for you. Adding to that, 37,765, modeled in this space below. Now we're going to pay attention to regrouping. So when I decide to add these numbers, I am going to start here in the smallest place of value, in the single ones place. And I'm going to do that because I might have to regroup. I don't know. Regroup? Let's find out. If I do have to regroup, then starting over here will save me just a little bit of extra writing time. Mathematicians love shortcuts when it comes to writing. So let's keep our hand relaxed and start in the lowest place of value, where I find that I have 4 ones plus 5 ones. Let me see. 4 plus 5 equals 9. Do I have to regroup? Nope. I can have 9 single ones in a spot, so I'll just write that in there and leave these guys down here. Let's move on to the next highest place of value, the tens, where I see that I have 8 plus 6. Whoa, you guys, I think I am going to have to regroup here. Yes, I do, because my sum is greater than 10. We can take these 10 tens and trade them in for 100. And I'm going to float it up here above my chart. So that's how we regroup when it comes to place value and adding. Now, here's what it will look like. Here's what I'll write down. 8 plus 6 is 14. I'll leave the 4 in the tens place and move those 10 tens from the teen up into the hundreds place because 10 tens equals 100. 10 times 10 equals 100. All right, so I did need to do some regrouping there. Let's see what's happening in my hundreds place, the next highest place. 1 plus these 7 gets me to 8. 1 plus 7 is 8. No regrouping there. I'll keep going to my next highest place of values and look at all those thousands. Oh my goodness. 6 plus 7, that was one of my hardest math facts in 2nd grade. So I'm talking so I give you a minute to figure it out with me. All right, we're taking these 6,000s and adding them to these 7,000s, and I'm remembering now that that can get me to 13. So I'm going to take these 10 single thousands and I'm going to trade them in for 1 10,000. And I'm going to put it right up here under my face because that's where I would write it. I would say 6 plus 7 thousands would give me 13 thousands, 3 single thousands and 1 10,000. And of course that brings me after that regrouping to the 10,000s place. Well, 1 plus 5 plus 3 will get me to 9 10,000s. Yep, I'll just write that down here. And there we go. I want you to notice how what we did with the chips here was happening in real things, and the way we wrote stuff down matched what we did with the manipulatives. Boys and girls, whatever you do in math should be able to happen in real life. So we're going to do that when we regroup. And visualizing and imagining it is so important because remember, math is supposed to make cents. Now, with subtraction, we will model a little differently. And to help us make sense of that, it's a good idea to take a look at our bar models for addition and subtraction. For the problem we just did, we had one part that I told you, and then another part, and we put them together, and in our answer, we found out what the whole thing would be. But in subtraction, we're going to start with the whole thing and then break it into its two parts. One part we will already know, that's the part written down here, but this part we will find out. So I have just modeled the whole thing here, which is 62,485. I once again am going to start in my single ones place, just in case I need to regroup. I don't know. Let's see if I can do it. So 5 minus 7, can I do that in positive numbers? No. So I'm going to have a chance to regroup right away. That means I'm going to take away one of these 10s. And how I will show that action happening in writing is I will cross off the 8, because if I take one away, I don't have 8 anymore. I will have 7 left over. I'm going to trade that 10 in for 10 single ones, like this. How I would show that in writing is I'm going to cross out this 5 and write 15 up here. Some people like to rewrite like this, and that's a fine way to do it. I'll show you another way in the tens place. So let's see now. I have 15 single ones, and I can definitely take away 7 like this. There they are for the 7 single ones, and then I'm going to have 8 left over for my answer spot, like this. How will I show that on my paper? Well, I had 15. 15 minus 7 equals 8 single ones. Whew, I'm glad we started in the single ones place so we could do that regrouping. Now I'll go one place of value up to see if I have to regroup here. What I have here now is 7 minus 8. I can't do that in positive numbers, so I'm going to go ahead and do some more regrouping. To regroup, I'm going to take away one of my hundreds, which leaves me with only 3. So I'll show that on my paper by taking 1 away from 4. I don't have 4 anymore, so I cross it out and leave 3. And so now I have 17 tens. I'll show that on my paper by squeezing that 10 in right next to the 7. I love to squeeze when I'm regrouping, friends. You can rewrite it like I did in the ones place, or squeeze with me like I did in the tens place. Now I have plenty of single ones to do 17 minus 8, and there are the 8, which leaves me with 9 single ones to move down into my answer spot. Now on our paper, this will look like 17 minus 8 equals 9. Okay, we did our single ones, we did our tens. We're going to do the next greatest place of value. Do we need to regroup here? 3 minus 3 equals 0. I don't think we have to regroup. I think we can do this one in positive numbers. The way that would look would be moving the hundreds down here so they match these 3 right here, and we have 0 in the hundreds place. Time to move on to our next greatest place of value, the thousands. We have 2, but we're supposed to give someone 4. Do I have enough to do that? Not in positive numbers. I can't do 2 minus 4 in positive numbers, so I'm going to do some regrouping. I'm going to take away one of my 10,000s, and of course, on my paper, I will cross out that 6 and replace it with a 5, because that's how many I have now. And then I'm going to go ahead and trade that one 10,000 for 10 single thousands, like this. I'll show that on my paper by squeezing those extra 10 single thousands right there. And now I have plenty of single thousands so that I can take away 4 of them, like this, leaving 8 for our answer, which I will write in the single thousands part of my answer right here. That gets us finally to our greatest place of value, where we have 5 minus 5. I think that I can do that in positive numbers as well, just like this, which leaves me with none. I can choose to write a 0 here if I want to, but I don't have to. There are zeros in all these places of values already. We just don't record them because we're not using them right now. So if you put all those zeros there, your answer is still correct. However, I don't like having those extra zeros there, so I will record my 0 as leaving it blank. Now, it turns out, your teachers know this, that subtracting from a whole group of 10,000s, or a really big number with lots of zeros, turns out to be wicked hard because you can fall into some patterns without making sure it makes sense. So we're going to do 50,000 minus 17,898. It's really simple to model this one. There are my 5 10,000s. But I'm going to probably have to do some regrouping here, aren't I? So once again, I'm going to start in the smallest place of make over the years. They decide, oh, it doesn't matter what order I do these in. 8 minus 0 equals 8. But does that work for subtraction? It does with addition, but it does not with subtraction, my friends, because we're starting with the whole thing. So we can't do it that way. We have to keep thinking what makes sense. In subtraction, I have no single ones, but I have to give you 8 of them. Do I have any to give you? No, not in positive numbers, so I'm going to move to the next highest place of value, where there's another 0. Now I only get single ones from the tens place, but to give the single ones a 10, I'm going to have to get some tens. Do I have anything in the hundreds place? Nuh-uh. So I can't give any tens to the tens place if I don't have hundreds. Now I can only get hundreds from the single thousands place, but there's nothing there. So my regrouping is going to take me all the way over to the 10,000s place. So I'm going to have to take away one of those 10,000s and trade it in for 10 single thousands. Now what that will look like on your board is this. I took away one 10,000, leaving me with 4, and that gives me 10 single thousands. And I'm going to squeeze here, and here's why. I know I have to do some more regrouping. So I'm going to take away one of my single thousands, leaving me with 9, and here's what that will look like. And I'm going to trade in that single thousand for 10 hundreds, like this. And there they are. But I've got to record this over here. I'm going to do some squeezing and record those 10 hundreds right there. But the reason I wanted hundreds is because I needed tens. So I'm going to go ahead and take away one of these 10 hundreds, leaving behind 9. Of course, the way I would show that on my paper is I'd cross out 10 and leave 9. I'm going to now regroup that single hundred into 10 tens for my tens place, like this. To show that on my paper, I will squeeze that 10 into the tens place, because now I have 10 tens. But I got those tens because I needed some single ones. So I'm going to take away one of these tens and trade it in for 10 single ones, like this. To catch my writing up, I have to cross out my 10 in the tens place because I've only got 9 there, and put the 9 right there, and I'm just going to squeeze that 1 right in here. Now we've done this regrouping to get 10, then give away to 9, to get 10 and then give a 1 away so we have 9, to get 10 to give 1 away so we have 9. A lot of kids fall into that pattern, and what they do is they just keep going, like this. But do I need to regroup right here? I don't. My whole reason that I started regrouping is that I needed to subtract something in the single ones place. So if we cross it out and make it a 9, that will not help us to be correct. It will help us to be wrong. And we don't want that to happen. That's why thinking about sense is so important in math. But luckily for me, I can just go right ahead and do all my subtraction now. 10 minus 8 is 2, like this. And 9 minus 9 is 0, like this. 9 minus 8 is 1, like this. 9 in the thousands place minus 7 is 2, leaving me in the 10,000s place. 4 minus 1 is 3. So the answer to 50,000 minus 17,898 is 32,102. Friends, you already know this. I hope you've been reforming your connections. Please, as you do this, make sure you make sense. Do not fall into just doing steps. Your brain is not designed to remember steps. Your brain is powerfully designed to remember meaningful sense. Thanks for playing addition and subtraction with me. Remember to regroup. Bye-bye for now.